Okay, so let's unpack this. We've got this really interesting idea we're diving into today. Basically, think of the big cloud players we know, like Netflix, Facebook.
Yeah.
They're the jumbo jets. Huge, efficient, built for mass distribution, but now large-scale AI models. They're being called the starships. It sounds cool, but it implies something fundamentally different, right? A whole new kind of technological race. Our mission here is to figure out the three core ways AI is just completely reshaping the infrastructure underneath it all, starting with, well, how the data actually moves.
Yeah, that's a great analogy. And it really hinges on the goal. What are you trying to do? The jumbo jets, the traditional cloud app, their main job was, decentralized delivery, getting stuff out there. So the whole architecture is built around solving for throughput, managing that north-south network traffic, from the central servers out to the edge, out to you. Netflix's Open Connect boxes are like the perfect example. Little caches sitting right inside your ISP's building. Super efficient distribution. They handle, like 15% of global downstream traffic. Amazing.
Okay, yeah, that makes total sense for getting movies to millions. But the Starship, it's built for creation, not just delivery. So is the bottleneck the hardware itself then? How does that traffic look different from, say, the Netflix model?
That's exactly the right question. AI training, our Starship, it's all about centralized, super intensive computation, creation, like you said.
Yeah.
All the really heavy lifting happens inside one massive cluster.
Yeah.
So the network focus flips completely. It becomes east-west traffic, just constant, huge flows of data between thousands of GPUs working together. We're talking 70, maybe 80% of all data center traffic is just internal chatter between these machines.
70 to 80%. Wow.
Right. And here's the kicker. It's tightly coupled. This distributed training, it needs specialized gear like InfiniBand. Why? Because it has to be lossless. Unlike traditional cloud stuff that's built for resilience, if you drop even one packet during an AI training run, poof, that can completely tank a multi-million-dollar job. It's incredibly fragile in that sense.
Hold on. One dropped packet ruins millions. That feels like a totally different risk profile. That resilience failure must just ripple through everything. How does that affect the life cycle, the whole development process? Because that sounds like it changes the economics big time, which I guess leads us straight to the second point, the ground preparation cost.
Absolutely, it changes everything.
Yeah.
The traditional software development lifecycle, the SDLC, it's iterative, sprints,
Yeah.
agile.
Hmm.
The main cost driver there is human capital. Engineers' time, salaries,
Yeah.
measured in person months, AI.
Yeah.
It's totally different. It's dominated by compute capital. The life cycle is massively front-loaded,
Yeah.
huge amounts of data prep, data engineering, and then this one giant monolithic training event. It's almost like an all-or-nothing bet.
Okay, and here's where, connecting those dots gets really interesting for you, thinking about the actual dollars. Cloud development cost, sure, it adds up, but it's engineer time. A single training run for one of these big frontier AI models. We're hearing numbers like $4 million on the low end.
Yeah.
Up to potentially over $200 million. $200 million. I mean, that's like launching a small satellite, basically, just for the training phase.
Yeah.
That really puts the high-stakes bet idea into perspective.
It really does. And that enormous upfront capital expenditure, that CapEx, that's exactly why this game inherently favors the players with the absolute deepest pockets. It fundamentally shifts the competitive landscape away from, say, the classic startup model.
Yeah.
Now it's about who can afford the massive infrastructure investment.
But that investment, it seems to pay off in sheer speed, right? Which is our final point, the takeoff speed. The rate AI is being adopted is it's off the charts. Traditional apps like Facebook, they needed network effects. There was friction. It took Facebook, 4.5 years to get to 100 million users?
Exactly. And generative AI, like ChatGPT, it hit 100 million monthly active users in just 2 months. It's that difference, right, between needing your friends to join to make it useful, that's the network effect friction, versus getting immediate, powerful utility the very first time you log in.
Yeah.
It's inherently valuable, instantly.
And the capability itself is improving just as fast, it feels like.
Oh, absolutely. The capability improvement is also exponential, and it's directly tied back to that compute investment we talked about. You can actually measure this on benchmarks, things like MMLU, that's massive multitask language understanding. Unlike the sort of steady linear improvements we saw in cloud like video getting clearer, going to 4K AI capability is taking these huge revolutionary leaps. And those leaps correlate directly with scaling up the compute power, the FLOPS.
So pulling it all together then, the Jumbo Jet was about aerodynamic engineering, mastering distribution efficiency on a global scale. The Starship, though, it's like propulsion engineering. Brute force creation powered by massive computation. The competitive advantage, the moat for this next era. It isn't just clever software anymore. It seems to be about access to just staggering amounts of compute capital and data.
That's the core shift. And the really crucial implication here, the thing for you to chew on, is how this incredible accelerating digital demand interacts with our very physical, non-accelerating world. AI capability improvement seems exponential, tied directly to scaling infrastructure. But what happens, what has to happen, when those accelerating, almost insatiable demands for AI training run headlong into the hard physical limits? Limits like available power, the ability to cool these massive data centers, even just the sheer real estate needed. That collision seems inevitable.